confirmatory factor analysis, abbreviated as CFA, for data extracted from a questionnaire or a scale or a survey, or even to develop a measurement which is based on a Likert scale. In this video, I will first define and describe the confirmatory factor analysis, and then I'll move to mention and list assumptions that have to be fulfilled before performing the CFA, and then I will describe and list some of the application of CFA before finally describe the steps that have to be followed to perform confirmatory factor analysis. So what is CFA? CFA is a special form of factor analysis. So it is part of factor analysis, as factor analysis can include principal component analysis, exploratory factor analysis, and confirmatory factor analysis. So exploratory factor analysis, EFA, will identify the underlying latent factors from the items or variables included in the analysis from a data taken from a questionnaire or a survey. So CFA is used when there are prior knowledge about the structure of the variables, the relationship between items or variables, and which items measure or represent factors. So first of all, EFA has to be done to sort out and assort and group items into factors, and then the CFA can be performed. So once EFA is done, then the CFA can be performed with a new set of data. So once this new set of data are collected, then the confirmatory factor analysis will examine and confirms structure or structures of latent factors produced from the EFA. So EFA will generate a model, a structure for the data by sorting them out or arrange them into groups called factors or latent factors. Each factor will contain a number of items or variables that measure that factors. Then the confirmatory factor analysis will confirm or disconfirm the output from the EFA. So first EFA has to be performed, then the CFA. The CFA is a complex approach that tests the hypothesis that the items are associated with specific factors. So it is an approach that you have already a pre-established, pre-known model for the data, factors and their associated items or variables. So CFA is hypothesis driven. It is used for testing a pre-established hypothesis. This hypothesis will describe the structure and the relationship between observed or measurable variables and the underlying latent factors. So the aim or aims from the CFA is to confirm or disconfirm factor structure based on prior knowledge, prior analysis from the EFA. So it tests whether the data fit a hypothesized model that describe the structure of the factors and the items that associated with that factor. So CFA will impose a structure on the data and check how well the data fit this pre-specified factor structure or model. In CFA, the number of factors are already specified, determined, known in advance, as it has been determined by the EFA, exploratory factor analysis, with variables that load on each factor. So we know the number of the factors and the items that associate or load or measure that factors, and the relationship between factors and their observed or measurable variables. The CFA will validate this theoretical model and assess how well the observed data, the new collected data, fit the proposed model that is proposed from the EFA. So researcher or statistician will specify the theoretical model with hypothesized relationship between latent factors and observed variables. So CFA will test how well a pre-specified factor structure are confirmed by the observed data. So it can test the latent factors are correlated in the model. So it can also not just test whether the items are associated with specific factor, it also can test latent factor can correlate to each other, or i.e. latent factors covary. So the CFA uses the structural equation modeling, which is SEM, to test a model whereby loading into that factors allow for evaluation of the relationship between observed variable and unobserved variable. So to recap, CFA is a following step post doing EFA. In EFA, the number of factors and the items that measure or load into the factor or factors will be already determined through EFA. Then the CFA will use a new set of data to test that model and to test whether these items fit into that factors and there is a relationship between the items and factors. In this slide shows the factor structure, i.e. the model proposed by the exploratory factor analysis. Here, as shown, there are two factors, factor 1 and factor 2. Factor 1 loads into it 3 items, and factor 2 loads into it 3 items, and factor 1 and factor 2 can co-vary. So there is a loading for each item to that factor. So this is the structure of the model that can be proposed or hypothesized or determined by the EFA to be tested in the confirmatory factor analysis. CFA can be used for validating measurement instruments when designing a questionnaire or a scale or a survey. Then the CFA can accurately assess the intended latent construct. So for validating survey or questionnaire, assessing construct validity, that's one of the applications of CFA, testing theoretical models, and identifying relationship between variables or items if it is a questionnaire or a survey. And also it can play an important part in scale development and refinement, as there is an option for removing some of the items that load into factors, so that there is a chance for a possibility for development of a questionnaire or a scale. It can be used also for quality assurance, for market research, educational assessment. Other applications of the CFA is to perform confirmatory analysis in mixed method research, in which there are qualitative and quantitative data. Also, the CFA is very vital for clinical assessment and diagnosis to develop tools for testing. So what are the assumptions that have to be fulfilled or satisfied before performing the CFA? The first assumption is the multivariate normality. Since the CFA look at several variables or several items, so it is multivariate analysis. So they have to be a multivariate normality. Assumes that the data follow multivariate normal distribution and variables are normally distributed both individually and jointly. The second assumption is linearity. Assumes that the relationship between observed or measurable variables and the latent factors or construct are linear. The third assumption is no multicollinearity. The observed variables should not be highly correlated with each other, i.e. items within factor or factors should not have a high correlation value or coefficient. The fourth assumption is absence of outliers. Outliers are an extreme high or low values in the data that deviate from the rest of the data. The fifth assumption is the reliability and validity of measurement. It assumes that the observed variable are reliable and valid measures of the underlying construct or factor. The sixth assumption is that there should be sufficient sample size. Relatively large sample size to produce reliable estimate or estimates is needed. So the sufficient sample size should be greater than 200. The seventh assumption is the independent or independence of observations, which assumes that the observations are independent of each other. The eighth assumption is that there should be a correct prior model specification. There should be a model with known factors and known items that load to each specific factors. So assumes that the specific model correctly represent the relationship among the observed variables and the latent factors extracted from an output or an outcome from the exploratory factor analysis. The ninth assumption is the absence of measurement error. The assumption states that they should assume that the observed variable are measured without error. The 10th assumption is the normality of residuals, that assumes the residuals, which is the difference between observed and estimated values, are normally distributed. And the 11th assumption is the data must come from random sample. So to perform the CFA, several steps have to be followed. The steps to assess the fit of the specified model to data. So we've already had a model which is obtained, generated from a previous analysis. Then the way to assess whether the data fit that specified model. There are several steps. The first step is to define the research objective and hypothesis. The objective is the primary goal of CFA is to assess the fit of the hypothesized factor structure or model to the observed, measurable, or obtained data, a new set of data. The hypothesis states that or formulated about the relationship between observed variable and latent factors. How many factors are there? Which items associate with which factor and load to that factor? And the CFA is then used to confirm or reject the theoretical model proposed by a previous analysis through EFA. which indicates can be accepted or rejected based on the outcome of the CFA analysis. The second step is to prepare the data. You need to screen the data and examine the data for missing values, outliers, and distributional assumptions. Data meet the assumption of multivariate normality, and transformation is done if assumptions are violated. So if the data does not follow normally distributed, that's a violation of the assumption. The alternative way to resolve that is to transform the data. There should be also no missing data when screening the data to perform CFA. And a way to deal with missing data through imputation. For a missing data, add the median or the mean according to the data type. Variable selection include the variables that are theoretically relevant and have a meaning factor loading. So just only include items that measure or load to a specific factor as determined by the exploratory factor analysis. The third step is to specify the model. Define the latent factors and their observed variables. Specify the relationship between the latent factors and observed variable, which is the factor loading. So you need to specify the model, build up the model as shown previously in the slide, which shows the model, the structure for the factors and the items loading to each factor. Draw the model. The next step is to estimate the parameter. Parameter estimation is that they estimate the model parameters including factor loadings, variances, and covariances, and to select fit indices and to choose the appropriate fit indices to evaluate how well the model fit the data. So common indices that can be used and are commonly used are the chi-square, the comparative fit index, which is abbreviated as CFI, and the Tucker-Lewis index, the root mean square error of approximation, which is RMSEA, and the standardized root mean square residual, SRMR. So these are some of the indices and the most common indices that can be used to determine whether the model fit the data. So then the next step is to run the confirmatory factor analysis using statistical software, whether R statistics, whether Amos, and any other statistical software. So there is a software which is part of the SPSS called Amos that can perform that analysis. So use this software to estimate the parameters for your CFA model. Review the output for factor loading, standard errors, and modification indices. Then evaluate the model fit. This is a giant step that need to be taken cautiously, as this will determine and assess how well the proposed model fits the observed data by examining the indices and comparing observed values to recommended thresholds for good fit. So some of the indices that can be used for assessing the model fit is the chi-square test, C min divided by DF. The second one is root mean square error of approximation, which is abbreviated as RMSEA. The third one is standardized root mean square residual, SRMR. And the fourth one is Brown-Cudeck Criterion, PC. And the fifth one is Comparative Fit Index, CFI. The sixth one, Pentler's Comparative Fit Index, PCFI. And the seventh is parsimony comparative fixed index CFI. The 8th is goodness of fit index GFI, adjusted GFI. The 9th is normed fit index NFI and non-normed fit index. The 10th is cake information criteria AIC. The 11th is the Bayesian information criterion PIC. And the 12th is the expected cross validation index. So those are the most listed indices that is generated as an output from CFA analysis. Not all of them are considered. The most common one will be described later on. So to assess the model fit is first of all to perform chi-squared test. As shown here, the CMIN is the minimum fit function chi-square statistics. Chi-square statistics goodness of fit statistic is performed to assess how well the proposed model fits the measured or observed data. So low value of CMIN indicates good fit between the proposed model and the data. High values, on the other hand, suggest a poor fit. So the measurement CMIN is sensitive to sample size. Usually the chi-square is divided by degree of freedom. CMIN divided by DF should be less than, equal to, or less than 5. And the significant level should be greater than 0.05. So it should be no significance. As the null hypothesis states that the model fit the data, and the alternative hypothesis states that the model does not fit the data. So this is a description and a list of an output generated from CFA analysis. As shown here, that's the degree of freedom is 8, the chi-square is 27.4, and the probability level is less than 0.05. So here this is an indication that the model is not best fit the data. As shown in the next slide, the default model as shown in CMIN is 31.5, DF is 8, degree of freedom. When this value is divided by the 8, it will generate 3.8. So this is okayish value, but the p-value here is significant. And the NPR stands for number of parameters for each model. The next index is the FMIN, stands for the index of the model fit. It is used and reported when the CMIN does not have the positive result, usually caused by a large sample size. The FMIN is described with boundaries expressed by low and high. Lower and higher boundaries of 90% confidence interval for FMIN. Value for FMN close to 0 represent better model fit for observed data, 0 value being the perfect fit. So the next slide shows a table extracted from CFA from Amos for model fit indices, and as shown here, the FMN is given here, and the lower boundaries for 90% and higher boundaries is given here, and the FMN value fit between these lower and higher. The next index is the Holter index, and as shown here, Holter index is a measure used if the chi-square is significant or not. So Holter 0.05 measure if the sample size is higher than the value specified for the default model. At 0.05, the default model should be rejected. For Halter 0.01, calculate if the sample size is higher than the number of specified for default model at 0.01 level. Default model may be rejected. The next index is the root mean square error of approximation, RMSEA. The index measures how well the model fits the observed data. The value for that index is ranging from 0 to 1. Smaller values indicate better model fit. To interpret the RMSEA values, any value less than 0.05 is excellent fit. Between 0.05 and less than 0.08, good fit. Between 0.08 and less than 0.1, acceptable, and any value equal to or greater than 0.1 is a poor fit. As shown here in this table, the RMSE value is 0.12, so it is a poor fit, and the lower boundaries, the higher boundaries, and the p-value for the null hypothesis is given here. So this value should be less than 0.05 to be excellent. The next index is the standardized root mean square residual, SRMR. The index will assess the goodness of fit of the structural equation model. It will provide the measure of discrepancy between observed correlation and correlation predicted by the model. So it's the value represent the average difference between the observed and predicted correlation, with smaller values indicating better model fit. So the value for it ranges from 0 to 1. Any value less than 0.08 is an acceptable model. The next index is the Brown-Cudeck Criterion, PC, is an alternative to RMSEA and SRMR. The value close to 0 indicate better fit. The next index is the Comparative Fit Index, CFI, is a statistical measure to assess again the goodness of fit of a proposed structural model to the observed data. CFI compares the fit of hypothesized model to null model with no relationship between variables. It assesses how better the hypothesized model fit the data compared to null. Value range from 0 to 1. If the value for CFI is less than 0.9, then poor fit. Anything between 0.9 and less, and anything greater than or equal to 0.9 and less than 0.95 is marginal fit. As shown here in this table, the CFI value is given as 0.94. And as described here, has a value, the CFI has a value from 0 to 1. 1 show a very good fit, value close to 1 very good fit, and 1 represent perfect fit. The next index is the Bentler Comparative Fit Index, which is PCFI. Is a modification of the CFI that corrects for the influence of a model complexity on a fit indices. The value closer to 1 indicate better fit. There is another index which is Parsimony Comparative Fix Index, PSFI. As shown here in the extract, the table contains the ratio value, the BNFI and the PCFI. It is a parsimony adjusted measure, that's relative fit index that adjusted for the majority of indices. The ratio is parsimony ratio. It's calculate the number of constraints put on a model used to compute the PNFI and PCFI indices. PNFI is the parsimony normed fixed index, and the PCFI is parsimony comparative fixed index. Another index which is for the goodness of fit index, GFI, and adjusted GFI, measure used to assess how well the hypothesized model fits the observed data. It evaluates the proportion of observed variances in the data that is accounted for by the model. So AGFI adjusts the GFI to account for the degree of freedom in the model. Interpretation of the GFI values. GFI and AGFI range between 0 and 1. Anything less than 0.9, poor fit. Between 0.9 and 0.9 and less than 0.95, adequate fit. Anything is greater than 0.95 is a good fit. Values of the GFI greater than 0.95 and AFGI greater than 0.9 is acceptable model fit, as shown here in the table. Shows that the GFI and the AGFI and the BGFI and the RMR. Another index, which is the RMR, stand for root mean square residual. Smaller the RMR value, the better. The value for it 0 represent a perfect fit. Another index is the normed fit index, NFI, and non-normed fit index, which is NNFI. NNFI, also known as Tucker-Lewis index, TLI. The values for NFI and NNFI range between 0 and 1. Cutoff for the value is equal to or greater than 0.95, indicate a good model fit. The next slide shows the table taken from CFA with the indexes for NFI, RFI, IFI, TLI, and CFI. TLI is Tucker-Lewis coefficient, known as Bentler-Ponent non-normed fit index. Range from 0 to 1. Value close to 1 represent very good fit. Value 1 represent perfect fit. For the NFI, normed fit index, also referred as delta, a value of 1 shows a perfect fit, and a value less than 0.9 can be usually improved substantially. The next table, the RFI, stand for relative fit index and is derived from NFI. Value close to 1 indicates very good fit, and 1 indicate perfect fit. For the IFI, incremental fit index, value close to 1 indicate very good fit, and 1 indicate perfect fit. The next index is the Archaic Information Criterion, AIC. It's a measure of the model fit that penalize model for their complexity. Lower values indicate better fit. So AIC often used for model comparison rather than absolute fit assessment, as shown here. AIC, PCC, PIC, and CAIC. It's measure the quality of statistical model of data sample to determine the model is the best fit for the data. The lower the value, the better. And another index is the Bayesian Information Criterion, BIC, is similar to AIC, PIC, also penalize model for complexity. Lower values indicate better fit. PC is also used for model comparison rather than absolute fit assessment. Shown here in this table, the PCC for Brown-Cudeck criterion, BIC for Bayes information criterion, and the last one for consistent Archaic information criterion. And another index, which is the expected cross validation index, ECVI, estimates the expected fit of the model to a new data. Lower values suggest better fit, as shown in the table here. the lower boundaries and the higher boundaries, and the MECVI is given. So there are plenty of indexes here, as shown the NCP non-collinearity parameter with the lower and upper boundaries and the value to look at. In conclusion, for SEM, at least the following indices should be reported: the chi-square, the RMSEA, the SRMR, and the CFI. So there are many indices. Those are the major, the common, the most reported in the literature or when presenting the analysis. Another step to do when performing the CFA is to assess the factor loading by examining the values for the loading to ensure that they are significant and meaningful. High factor loadings indicate strong relationship between the latent factors and the observed variables. The next step is to examine the residual. Why? To check the residual to identify any patterns or outlier. Residual analysis help determine whether the model adequately expresses the relationship between variables. Another step to consider also model modification. Modification indices suggest potential improvement to the model. Only modify the model if it is justified. The 10th step is iterative process. CFA is often an iterative process to refine the model based on a result and a theory, and to rerun the analysis and to reassess the fit indices. If you find this video useful, do subscribe to the channel, leave any comment in the indicated box, and activate the notification bell to receive the recent and latest release into the channel of several different video clips, and click on the like icon and share the video link with others so the channel can expand and improve to include a large scope of different statistical method and how to analyze data using several different statistical packages such as SPSS, Excel, Stata, Jamovi, RStatistic or Statistics, GraphPad, Prism, GPower, Python, and RevMan. If you are a student or a researcher and you have a data, whether it is quantitative or qualitative, and you want to perform statistical analysis on that data using any of the softwares listed here, whether it's SPSS, Excel, Stata, Jamovi, RStatistics, GraphPad, Prism, RevMan, GMP, Python, then do contact me to arrange for either a one-to-one private tutor session or a training course on any of these statistical packages. My contact details are given here, so don't hesitate to write to me or email me if you need a private one-to-one tutoring or a training course.